Hello everybody, today we will solve certain gate fluid mechanics questions. We will see with explanations. These are previous year questions. So let's start. Before starting, I welcome you all to my channel Chemistry 19 Fundamentals by Chakraborty. I am a PhD from IIT Kharagpur. So our first question is free jet of water of cross-sectional area 1 meter, 0.01 meter square and a velocity of 20 meter per second strikes a plate and then flows in the plane parallel to the plate as shown in the the horizontal component of the force on the support, it has been asked. So how much is the force exerted on the plate? So we have to calculate the same. Now we know that if we do for this, we have to do a momentum balance. So what is momentum balance? Momentum balance is sum of forces acting on the control volume. If we take this complete section as a control volume, it will be rate of momentum in minus out plus rate of momentum accumulation in the control volume. So from Reynolds transport theorem, we can say that rate of momentum in minus rate of momentum out. If we do a momentum balance here, so this term gives the rate of momentum in minus rate of momentum out. Since you see here, this is rho, so this rho v, and we are having small area dA. So v dot eta cap. V dot eta cap is the velocity vector in the direction normal to the area vector. So V dot eta cap, when it is positive, it represents outflow, and when it is negative, it represents inflow in the control volume bounded by the control surface. Now, the accumulation term within the control volume is given by del T of volume integral of rho Vx dy. So, since it's a steady state condition when there is no accumulation of the volume, we can say that this term is 0. So, we are left out with rho Fx is equal to area integral of Vx rho v cos alpha dA, and we know that the free jet is coming at normal to the plate, so our alpha is 0 degree, so cos alpha will be 1, so we are left out with Fx is equal to Vx rho Va. So Vx rho Va is the rate of change of momentum along x direction, and Fx represents the horizontal component of force. So if we put these values in the above equation, we will find the force Fx as 20 meter per second into 1000 kg per meter cube 20 meter per second into 0.01 meter square. So give the product of 4000 kg meter second to the power minus 2. So our option D is the correct answer. Now let us move to another example. In a fully turbulent flow, Reynolds number greater than 10 to the power 5 in a pipe of diameter d for constant pressure gradient, the dependence of the volumetric flow rate of an incompressible fluid is given by what it is. Option A d, option B is d square, C is d to the power 2.5, D is d to the power 4. So if you refer Mackeb, Smith and Harriet book, you see there that is pressure drop per unit length is 2F rho V square by D. It is given as the same. So Reynolds number is greater than 10 to the power 5. So F, this is friction factor. This is determined from Moody's plot. So completes this plot represents the variation of the friction factor during laminar and turbulent flow for various surface roughness of pipe. So Fx for this Reynolds number greater than 10 to the power 5, F is approximately assumed to be constant. That pressure drop per unit length, then our del P by L becomes also constant. So we are left out with V square is equal to del P by L d by 2F rho. So when we calculate the dimensions, we find that Q is now, if we replace the value of Q pi d square by 4 into V. So if we replace the velocity equation into this Q equation, then we will find that our volumetric flow rate is dependent upon d square into root over of d, that is d to the power 2.5. So our option C is here correct answer. Now the third question, sorry for this inconvenience, this would be the third question. It is represented as in a laminar boundary layer flow over a flat plate, the ratio delta by x varies as how it varies. What is boundary layer? So when a fluid flows over a flat plate on a surface, so the fluid element near to the surface has a value of 0 velocity, which is called no slip condition. that it is the skin friction or the friction there is the highest. So due to that, velocity adjacent to the surfaces becomes zero, and now as we move away from the surface, the velocity becomes closer to the bulk flow velocity, and after a certain distance from the surface we find that the velocity is approximately equal or 90% of the bulk flow velocity. So there the length required for that velocity to develop from 0 to the fully developed or to the free stream velocity is known as the boundary layer, that is boundary layer thickness. So for laminar flow conditions, the boundary layer thickness was determined by Blasius solution. The Blasius worked on it, and it is given as delta is equal to 5x by root over of Reynolds number. So if we take the ratio of delta by x, we find that it is proportional to 1 by Rex, or Re to the power minus 0.5. So option D is here our correct answer. Please keep watching my video. Please like, share and subscribe. In my next video, I will come with more fluid mechanics gate questions. For the time being, thank you and good luck with your preparation.